Well, hello there and welcome back to another Advent of Code video. So today it's a bit late already, but I figured I could try something out. Maybe only part 1 of the next puzzle, which will be day 23. Only 3 more puzzles to go, and look at this. Day 25 has 3 lines, and I haven't noticed this before. There's like some mountains. In the background it seems pretty nice. So day 23, what's it going to be about? Unstable diffusion. That's an interesting title and reference to that image generator AI thingy. I hope it's not anything as advanced as that. So okay, you enter a large crater of gray dirt where the grove is supposed to be. All around you, plants you imagine were expected to be full of fruit are instead withered and broken. Oh, how sad. A large group of elves has formed in the middle of the grove. But this volcano has been dormant for a month. Without ash, the fruit can't grow, says one elf, I guess. You look to see a massive snow-capped mountain towering above you. Nice. It's not like there are other active volcanoes here. We have looked everywhere. But our scanners show active magma flow. Clearly it is going somewhere. They finally notice you at the edge of the grove, your pack almost overflowing with random star fruit you have been collecting. This sentence is interesting. I wonder if you come to this problem without having solved many of the previous ones, like if this thing would change instead of saying like overflowing with random star fruits, it says something else with a couple of them. So okay, they notice you. Behind you, elephants and monkeys explore the grove, looking concerned. Then the elves recognize the ash cloud slowly spreading above your recent detour. How is the chest? Before any of them can form a complete question, another elf speaks up. Okay, new plan. We have almost enough fruit already, and ash from the plume should spread here eventually. If we quickly plant new seedlings now, we can still make it to the extraction point. Spread out. The elves each reach into their pack and pull out a tiny plant. The plants rely on important nutrition from the ash, so they can't be planted too close together. There isn't enough time to let the elves figure out where to plant the seedlings themselves. You quickly scan the grove, your puzzle input, and notice their positions. For example, okay. The scan shows elves as hashes and empty ground as dots. Outside your scan, more empty ground extends as a long way in every direction. Okay, so this is kind of like an infinite grid. The scan is oriented so that north is up. Orthogonal directions are written N north, S south, W west, and E east, while diagonal directions are written northeast, northwest, southeast, southwest. The elves follow a time-consuming process to figure out where they should each go. You can speed up this process considerably. The process consists of some number of rounds during which elves alternate between considering where to move and actually moving. This kind of seems like a cellular automaton kind of thing, like they are going to be moving around to plant those plants. During the first half of each round, each elf considers the 8 positions adjacent to themselves. If no other elves are in one of those 8 positions, the elf does not do anything during this round. Okay, if no other elves are around in one of those 8 positions. Okay, they do nothing. Otherwise, so it's like the stable configuration, I guess. Otherwise, the elf looks in each of the 4 directions in the following order and proposes moving 1 step in the first valid direction. If the elf, if there is no elf in the north, northeast, or northwest adjacent positions, the elf proposes moving north 1 step. If there is no elf in the south, southeast, or southwest adjacent positions, the elf proposes moving south. Okay. If there is no elf in west, northwest, southwest, the elf proposes moving west, and then for east is the same thing, proposes moving east. Okay, so they look in each direction, kind of it's an open cone, and if there is no other, basically they will move there if there is no elf to be touching them over there. They want to be spread around. After each elf has a chance to propose a move, the second half of the round can begin. Simultaneously, each elf moves to their proposed destination tile if they were the only elf to propose moving to that position. If 2 or more elves propose moving to the same position, none of them of those elves move. Okay, interesting. So they can be, they can lock each other, I guess. Finally, at the end of the round, the first direction the elves consider is moved to the end of the list of directions. For example, during the second round, the elves would try proposing a move to the south first. Oh, okay, so this list of 4 conditions is kind of like shifting around in each turn. Then west, then east, then north. Okay. On the third round, the elves will first consider west, then east, then north, then south. Okay, makes sense. As a smaller example, consider just these 5 elves. Okay, so there are 5 elves here, a group of 3 and a group of 2. The northernmost 2 elves and southernmost 2 elves all propose moving north, while the middle elf cannot move north and proposes moving south. Okay, the middle elf proposes the same destination as the southwest elf. Okay, so this guy is going to be moving south and this guy is going to be moving north. So they are going to propose the same destination. So neither of them move, but the other 3 do. Okay, so these 2 move north and this one move north also. Next, the northernmost 2 elves and the southernmost elf all propose moving south. Of the remaining middle 2 elves, so these 2, this cannot move south because it's blocked by this and this is blocked by this one. Okay. Of the remaining middle 2 elves, the west one cannot move south and proposes moving west, so left, while the east one cannot move south or west and proposes moving east. Okay. All the elves succeed in moving to their proposed destinations. Okay. Finally, the southernmost 2 elves choose not to move at all. Of the remaining 3 elves, the west one proposes moving west, the east one proposes moving east. So this one goes to the west, I guess in the order of these instructions. This was going east, I think. Yes. And the middle one proposes moving north. All 3 succeed in moving. So now it looks like they are all pretty spread. So I guess at this point they should stop. At this point, no elves need to move, and so the process ends. The larger example above proceeds as follows. Okay, so we have, I'm not going to interpret what is happening here, but we have all the spreading around. After a few more rounds, end of round 10, they look like this. Okay. To make sure they are all on the right track, the elves like to check after round 10 that they are making good progress toward covering enough ground. To do this, count the number of empty ground tiles contained by the smallest rectangle that contains every elf. The edges of the rectangle should be aligned to the north, south, west directions. The elf do not have the patience to calculate arbitrary rectangles. Okay. Yeah, it would be a completely different challenge if you had like to put the smallest rectangle in here, and it can be turned, yeah, like a tilted rectangle. In the other example, that rectangle is this. In this region, the number of empty ground tiles is 110. Simulate the elf's process and find the smallest rectangle that contains the elves after 10 rounds. How many empty ground tiles does that rectangle contain? Okay. Sorry, it was a little bit mumbly today when reading this, like even more than usual. Let's go and check the inputs. Okay, so it's a pretty large map, but not humongous. It's pretty packed with elves too. So I wonder, like part 1 doesn't sound too complicated, at least, or I say that and I'm probably going to be very bad at solving this. But I wonder what part 2 is going to be about. Like if this thing contains a lot of elves, so maybe they will ask to simulate this until it converges, until they are all spread out, and maybe that thing takes a long time. I don't know, but we shall see. Let's go to admin.code and fire the text editor and do the usual thing. So we're gonna be day 23. This is unstable diffusion. Whoops. And add to the array of days. And add the file. Add the usual run function. Okay. And let's add the input. Now I have the test thing for day 22, but I think I left that test exploding. Yeah. I should probably either remove that test or comment it. Skip test. Ignore. Okay. So yes, you're a nice test, but you should be ignored. I wonder why Rust doesn't use these attributes, kind of like, oops, I am screwing around with shortcuts. It doesn't prefer like to format these things like this. Well, I guess it's very similar, but for some things I guess it would make more sense to have them in line. But anyway, if we do that and we run the test now, ignored. That is fine. And unstable diffusion. Okay, so how are we going to do this? I guess the first step will be to parse the elves. What am I looking for? Oh, I was also going to copy this input file, day 23 txt. Have the input, so it's 74 lines and 74 columns. Interesting. That's an interesting number. Why not 75? Well, I don't know. What do we want to do? Probably we would like to simulate the smaller example first. Yeah, let's do that. And I'm probably also going to try to do the test thingy, but before, let's try with just a small input. Okay. So I guess the parsing should be easy enough. I was thinking about whether we should use like 2D vector or something else like a hash map for this, and or even a hash set just with the elves coordinates. And I am gravitating toward the latter because if we start like this or with the bigger inputs and we create a vector like that, things are going to spread to negative indexes. And of course, if we are simulating 10 rounds in the first part, we can pad this thing with 10 positions in each direction, and that will be enough for 10 rounds because elves won't be able to move more than 10 positions per round. But I think it's going to be simpler to just use a hash set. So let's go with that. Let's say let elves just parse elves and pass the inputs here. Generate this. This is going to return a hash set of, and I'm going to define a type alias for this. On the previous day, day 22, I ended up refactoring this solution a little bit to have also like a point type alias and use more of this, and instead of passing XY coordinates everywhere, just pack them into a point, and I think it makes some things better. You can always destructure when you need to access them. But I guess I'm also going to use 32-bit numbers. Why not? And they need to be signed, so we don't care about negatives, or negatives don't bother us. So here we are going to get the inputs. Lines. I guess we're gonna need to enumerate them because we're going to need their number, and then map this thing. We're gonna have each line, and no, sorry, this would be position Y in the shape of a tuple, and the line, and finally we are going to collect. And then for each line, we're gonna do something similar. I guess we can do it with chars. What do we want to do here? Also enumerate, and map, and collect. And the map would be with X coordinates and character. We're going to match the character. If it is a dot, I guess we don't need to match. We can just say I guess we need to filter, right? These things. Yeah. Let's do that. First, let's filter out the ones that are else, actually. So we're just going to say filter if the character is a hash. I'm not going to use this, and then we are going to map. Yeah, and I'm going to use this. We are not going to use the character. and we're gonna map into a point with x and y. And this collect is probably complaining about I32s, because yes, these things are U size, and you don't like this because this is a reference to the character. That is fine, and you can be as I32 as well as you. And then this thing should be actually a flat map, right? Why not? Flat map. I can't do that. Wait, I think we should be able to do this. Although okay, so yeah, we don't need to collect in the inner like for each line. We can just return an iterator here, and this is going to be all flat mapped into the like flat collection of the hash set. So okay, we have the elves. Maybe we can print them. Format elves, and we have the sample input. So let's say cargo run 23. So this is XY 31 34 22. Well, at least there are 5 of them. Let's see, on the first, like y equals 1, there is 1 in x2 and in x3. So yeah, this looks all right. There's not much there to screw up. So then let's implement the logic, I guess. What are we going to do? We're gonna go for whatever like we're going to repeat 10 turns or rounds, I guess. And we're going to do this logic of first seeing like which directions they want to move and then moving them. So I wonder, we have to like make these things shift in every turn. So I wonder, for that we could have like an array of 4 positions and just cycle that, or even a counter in probably an integer counter would be even simpler. I wonder how to model the directions. I'm thinking of, like, the obvious thing would be to have an enum and say something like, well, north, northeast, east, southeast, south, and so on, and then implement this as checking conditions. But I think like, how are we going to, I guess another thing, like, instead of directions, we could an enum we could also have like constants. Well, let's say north is going to be a point, and it can be in the x direction 0 and -1 in the y direction, and same thing with all the others. North, east, well, southwest, you get the point. And I guess I can go clockwise, so northeast, then east, and so on. is this going to be good? Because with this we can use these directions to access, like already add these things to a position of the elf and then check the neighbors from there. So we're gonna say something like, okay, 10 rounds, we're gonna iterate over all the elves and sort of annotating, take note of where they want to move. So I guess we can have, well, we could have like some state for each elf besides the position. I realize also that this is going to be mutable if we want to move them around. And I was saying like they could have some state to save their decision of where to move, but maybe we can have like another hash for that. So we're gonna say, okay, for each elf in elves, how are we going to do this? Yeah, one thing we could have, like I don't know if I can say like, okay, if it makes sense to say something like, let's how is this thing called? Each of 4 directions in the following order and proposes moving in the first valid direction. So we could say, I guess, directions be north, south, west, east. Imagine we have the others defined. Yeah, but if we do this, it's like when we are checking, we will have to know that when deciding whether to move north, we also have to look at northeast and northwest. And I don't know of like a sensible or as an obvious way to know that from the direction itself. Probably there is, but I think I'm going to just express it as it is expressed like here, like north, northeast, and northwest. So we will have an array of arrays of directions. So this north, northeast, and northwest, right? Then south, southeast, and southwest, then west, northwest and southwest, west and southwest, and finally east and northeast and southeast, I guess. And we have to define these constants. So we're gonna go then, well, we're gonna have 1, 2, 3, 4, I think. So north, northeast, east, southeast, which is going to be 1, 1, then south, which is going to be 0, 1, then south west, which is going to be -1, 1. Oh, I'm also noticing, yeah, that's of course northeast is just north and east added together. So that might make things simpler, I guess. Yeah, but let's forget about that and just define this as this. So southwest, west, and northwest. Southwest is west and south, and west is going to be west and nothing, and then this is going to be west and north. Okay, very good. So we're going to have these directions, and we want to, on each iteration, we are going to move like an index forward. So let's just have an index here. Let's direction index start at 0. It's going to be mutable, and after each round we're going to increment it. Direction index is going to be direction index +1. All of this mod 4, I guess. Then, how do we decide this? I guess first, if there is no other elf in the 8 neighbors, we can say, okay, do nothing for this. Which I guess is the same as checking, checking each of the conditions, and if we didn't make any decision of where to propose a move, then we don't propose a move and we do nothing. So, okay, that's also a possibility. So we're gonna say something like for each instead of calling this directions index, let's call direction start direction index. So for I in we're gonna start at the start direction index, and actually we could, there's a much simpler way of doing this. We could use this variable for this is the round number. We don't need this mutable thing, and we can just say for I in 1 to 4 ask, like, let's say there's, like, we are going to, like, these are the directions that we want to check, right? So we want to access this directions array, and we can access it with round mod 4 plus I. And what do we want to say here? We want to say something like if all of these 3 directions, there should be an array of 3 points, right? Yes. If all 3 of these are empty, then we propose moving to the first one of those 3. Yes. So if there's every, I guess I have to do iter. This is going to be neighbor X and neighbor Y. And I guess instead of saying, well, elf is going to have an XY coordinate, but yeah, we're going to need those XY coordinates of the elf. So let's extract it. I don't know if I'm going to need the elf itself. Probably I do, because I want to move it. Wow, but we can construct it again from X and Y. Anyway, what do we want to do? We want to check if every of these neighbors is empty. So else, we're gonna access, I guess get is what I want. Is there a has or contains? Yeah, there is a contains. So do you contain x plus, I guess this is, yeah, neighbor x, let's say dx and dy. X plus dx and y plus dy. If you contain it, it means that there is an elf, so we are not going to move there, and we should continue on with that with the different directions. But if it's empty, which should be this, if all of them are empty, so many parentheses here, then we're gonna break this loop. Is match type, yeah, sure, have a reference. I guess we can extract this thing into a variable to make it more readable. This means direction empty. Yes. So if the direction is empty, we want to propose a move to that direction. And I guess I'm going to put that in another hash set or hash map, like because the thing is, we can record every move, but then if two elves are moving to the same place, then we do nothing. So this could be like a hash map of point, like the point where we want to move, and a vector of points, like which elves want to move to that point, right? Could be something like this, but and of course we could also put the moves directly into like a vector, but that would suck, because wouldn't scale very well, because then you're not going to just execute the moves. You're I guess this should be like a vector of point to point, like these elves want to move to this point, but then you would have to, for each of these, you're going to want to see if there is any other entry on the array. So it's a linear search for each, and it would be like a quadratic thing. And for the large inputs, I'm suspecting that might be a bit slow. So do we want actually a hash map like this? Actually, I think yeah, if we only have like something like this, for each like the key would be like the point where we are going to move, and the value would be like the elf that wants to move there. So we could have something like to be, because we only care about like two cases. If there is only one elf, then it's okay. And if there is more than one, we don't care whether it's 2 or 3 elves that want to move there. If there is more than one, that's enough already. The move will not be executed. So this could be like something like option point, and say, okay, when it is some point, it means that some is the elf that wants to move there. And when here, when we are determining the moves, the proposed moves, if there is already an elf that has proposed a move there, we can put none here. That would work, I think, but it's a bit like difficult to understand. And also because the hash map API is like many things that return like an optional, like you do get and you get an option. So you would get an option of an option, and that's a bit confusing. So I think I'm going to just define an enum for this, even if it is just like an option. So this will be move, how do we call it, proposal, propose moving. Let's call this, I would say like propose move. I don't know, I don't have a better name than move proposal. So a move proposal can be a single elf, which is going to be a point, or too many elves, which is the two conditions that I care about. So moves is going to be a hash map of those. Yeah, point to those. Oops. I can say hash map. Yeah. Okay, and I guess I can put the type in here. And of course, we need a turbo fish for this. Okay. So if the direction is empty, then we are going to propose to move there. And we're going to say, well, moves. How do we say this? I guess get mutes could be, and if we find nothing, we put only one, like we put the single elf on. If we, I think there is another API for this, yeah, the entry API, which has like a or insert. I guess it has like a default thing that is useful. Is this what I want, or insert? Entry, which key? So, okay, where we are going to move is the directions, well, the first one. I'm gonna say, I think it is this what I want. In place, immutable access to an occupied entry before any potential inserts into the map. Yes, I think that's what I want. Or insert a single elf. I guess move is fine. Yes, we can insert ourselves, right? And if there is something already, I don't know if this is the, you know, I don't think that this is the most readable API. Yeah, I sort of want to do like just get mute. Because this get returns a mutable here. But I don't know if you can. Yeah, no, if it's not occupied, that's the thing. You cannot do insert to there. You're gonna get none. Yeah, because this returns an option of a mutable reference. So if you have no mutable reference, it means like, okay, you haven't inserted. Yeah, that's why the entry API exists. Okay. So on modify, we're gonna modify this. Well, move is not a nice word to use. But I guess here, yeah, we have a mutable thing to this. So we're going to just insert into here, say too many elves, if there is something already there. And these, you found a reference here. Yeah, I guess we can. Oh no, it's not here that I want. I want to move. What am I recording here? Yeah, the elf that wants to move here. So yeah, we can put that. Yeah, right. And this is an array of hash map of moves. Entry moves as mutable as is not declared as mutable. Yeah, this should be mutable. Okay. I think this will be the first part of each round. If I didn't make any mistake, I would like to maybe print something here. So let's say println elf wants to move to, and it's not just this direction. We want to say this kind of thing. So let's say does this use the word destination? Yeah. So let's extract this into a variable, call it dst for destination, and I guess we can also extract these into dx dy. And say that destination is my x plus dx and my y plus dy, and wants to move to destination. Okay, and when in this case of and modify, I would like to also print like println destination already occupied, something like that. So I guess we can simulate a single round. And not print anything here. Let's see. Well, we got one message of destination already occupied, which is destination 2, 3. So x2 line 3, which is this one, and that looks nice. That looks to be alright to me. So maybe let's just let it go for all rounds. Let's also print the round number. Round. So after, I think in this little example, there were a few rounds, like 1, 2, and 3, I think. So after 3 rounds, we should see no more moves. Panicked. Wow. We have an error here. So, oh yes. This is a pretty dumb mistake. So it is the round plus I out of this mod 4. Go. Oh, they are keeping moving. Ah, okay. No. Yeah, that was a silly mistake. Like if there are already, if all the directions are already empty, then we want to not do anything. So that has to be something to be checked first. Okay, so so I guess we can, you know what, I'm tempted to say, hey, directions. I'm tempted to say something like, let neighbors be directions, and we're gonna map like each of these directions to the neighbor that's there, or just to true or false, like if it's empty or not. Yeah, like if there is enough or not. So map, this has another array of directions internally, so this we will also map to something like this. Okay, whether the else contain, so this is if there is a neighbor over there. So there will be some repetition here because this includes things twice, like northwest is twice here, but yeah, it's fine. And I want to say if let's all empty, it's gonna be neighbors all a condition. Here we will also say, hey, are you all, what is the type of this? Yeah, an array of bools. That is correct. We could also flatten this, but I think this is all right. So we're gonna say, hey, NS, are you? I don't know why the type. Sorry, the autocomplete is not working here. Are you like all false? What I want to say, or are you like all not occupied? So elf present. So are you all not elf present? Let's see. Oh, you don't have. Okay, yeah, because you want to be an iterator, and you also want to be an iterator. And I wonder if you can just ask all for an array of booleans, you know. Something like, it would be nice if arrays of booleans have methods for them, like to call these things more directly. So I'm not sure if I want to say neighbors occupied or not, but no, let's have the same logic. Although no, maybe we can say okay, like this, and say if they are empty or not. Empty. Okay, so all empty. Yes, come on, just be a nice boolean. So if all empty, then just continue with the next elf. Otherwise, you're going to go in each direction, and I think yeah, what we can do is, this is the index for direction or for neighbors. We want to check the neighbors. Like, it doesn't make sense to access the hash again here. That's why I extracted this neighbors variable. We just need to maybe use this index. Let's say their index, and here neighbors index. If all of the neighbors in this index well, are all empty, again you want to be boolean. The direction is empty, then we can access the directions with this their index, and then the first of those. Is this does this make sense? Yeah, I think it does. I think it does. So let's run now. We still want to make moves. Oh, of course they still want to make moves. They want to all make the same moves in the or very similar moves in each round, because we are not actually moving and they are not advancing. I don't know what I was expecting. We have to do the moves now, actually. But that should be relatively easy, I think. So we're going to say, hey, for move, that is not a good. Let's say this is going to be an array of proposed moves. For proposed, actually we can probably extract this thing. Proposed moves iterator. So this should be an iterator of key values, and this should be something like this, and this is going to be a value of this move thingy. Let's call it proposed move. So we're just going to say if let single move single elf this is the destination. Let's call DST. Let's just call it destination. DST and single elf. This proposed move. So for each of those, let's do the move. So we're going to modify the elves. So elves, I guess we want to delete or remove the current, well, the elf that is there, and then insert in the destination. And these match types. What's your problem? Oh, it's borrowed as. Oh, because we are still in the elf iteration here. That's not what we want. This should be in the outer loop. So this is the part 2 of every round. Okay, so let's run now. And that looks more promising. So we see moves in the first 3 rounds, and then they no longer move. So that's pretty similar to what we have. And in the round, like the last round of this one, did 3 elves move? Yes, I think there are 3 moves here, so this looks quite good already. So let's actually do this example of this is, I guess, the sample. And do I write a test for this? I'm tempted to maybe try that. Let's say const sample be this thing. Beautiful thing. Yeah. And can't you put the type of this? Come on. What are you complaining about? Yes, you're complaining about the type, but can't you write that type for me? Okay, let's copy the tests on day 22. Some boilerplatey thing. That is fine. Let's move this sample inside. Let's not ignore this test. And okay. If we do cargo test now, oh, something exploded. No, because yeah, in round 9, this sample, yeah, they are not all in their final positions, I think, in round 9. Yeah, now there are some guys touching. So that's fine. What we expect is the 110 number, but of course we are not calculating anything yet. So let's do that. What we want to then do is calculate the bounding rectangle of this. That should be relatively easy, I think. How do we do that? Let's say, min x, min y. Both of them are going to be immutable. And let's start at 0, 0, I guess. I don't know why I'm doing it. This is like a tuple, but whatever. And then we're gonna have a max of both. And we're gonna say for elf in else iterator. Let's reference this. Well, the minimum x is gonna be min x, and I guess here what I want is the xy coordinate of each elf. Mean between minimum and this x, and then same thing with max x, I guess. We're gonna do max x, yeah, and then we're going to repeat the same thing for the y's. Now, not so easy. Okay, beautiful. And then we should just say let area be this would be max x minus min x, and I think +1, because yeah, imagine like if there's only one elf, we will have min x and max x be the same number, so you have to add 1. All of this times same thing with y, max y minus min y +1. This is the area of the rectangle, and we want to know the empty empty tiles, so let empty tiles be area minus else length, and let's just print the empty tiles. Oops. How about that? Yes, as I thought it. Well, does it make sense to be yeah, whatever. Minus 21. What? That's interesting. What did I screw up here? Oh, yeah, I'm using min for everything. It should be max for this and max for this. That's surely an error. Still failed. 122. 32, sorry. What's the area? So prints, let's do a debug print. I'm not used to doing this, but it's pretty useful. We're gonna print the area and also the else length. Hmm. 164 and 22 elves, which I think I will believe it. Well, maybe I can. Yeah, it looks like 22, whatever. So yeah, the number seems to be correctly calculated, but we are not seeing the correct result here. That sucks, because in order to debug this, I think, yeah, the best idea would be to to print this thing and see where we are differing from the inputs. It's interesting that there are relatively few moves in the last. Well, no, round 8 has a lot of moves, but round 9 has few. There aren't that many how do you say, like, collisions. Relatively few of them. Yeah. Interesting. So, do we do the printing? I think there's not much other choice. Maybe one thing that we could do is to try to see, okay, end of round 10. So it starts with a padding of like only a couple, 3 on here and 2 on X. That's interesting, I think. And I think I'm going to copy this idea. So we are going to print this. After each move, we're gonna, well, after each round, we're gonna still print this round thing. Let's comment this printing to avoid some of the noise. And how are we going to do this? So let's just hard code this. Let's go from minus 3 or 4, like for X in like -4 to, so this is how many? 5? Only 5? Or 5, yes. So 5 plus 4, let's go to 9. And for Y in, oh, there's more space here to the right, so let's go up to 10. For Y in, I guess, similar. It's 6 lines. We are also going to go from -4 to, well, 7 plus 4. It's going to be, let's go to 11. Let's go to the same range in both. And we're gonna say, we can accumulate this into a line, right? Yeah, let's say, let's line string b, and actually we can use iterators for this. So we're gonna grab this and say, hey, map Y into well, a character. So we're going to say, hey, if else contains this xy, then we're gonna say the character hash, and else the character dots, right? And we're gonna collect this. And this, what's the problem? You want the reference? Sure. And then we're just going to print line, a line. You want this, okay. And then print line, an empty line in the end. Do we have some sort of drawing with you. Does this look anything remotely similar? Let's see. Oh, we are screwing something up here already, right? Like the Y is kind of funky. Actually, we can maybe print the start of each round, maybe. Because I want to see the starting condition too. So let's go up to 10 inclusive. Well, no, let's not go up to 10 because that will change the... Well, it doesn't matter because right now it's not running correctly. I just want to understand this. Oh, what the hell happened? Oh, that was not the... Well, but let's see with the test. Actually, this one should be simpler to follow. So we have... Oh, do we have it that's upside down? No, we're just... I think we are printing the map incorrectly. Yeah. This should be Y. And the line should go through X. Yes. Let's run again. So for the simple example, we start like this, which is all right. Then we have 2 moving up and then like that. That also looks all right. Then they move like this. Yeah, seems so. And then they spread out a little bit more. Yeah. So for the for the little example, it seems to be working fine, but not for the test. The test seems to be going a little bit. Does no one is going to. Something weird here for X, right? Starts at -4. What's happening here? Like the actual input does have, guys. Yeah. And here, this doesn't look right from the beginning, like the round 0. What's happening here? Like if we go from 0 to 11, what do we see? Round 2, round 0. Why do you see the X padding here? Like there should be some guys at 0. Does this even... No, wait, this doesn't even look like the sample, right? What's wrong with this? This guy has 1, 2, 3, 4. So this is sort of in the correct position, but then everything else is kind of shifted to the right. What's happening? Let's start also at 0 for Y. I'm confused. We created the map wrongly in the first place. Yeah, no, this still looks wonky. This is kind of weird. So either we are parsing things incorrectly. Oh, I think I know what it is. What an idiot I am. The editor screwed up with me, like internal white spacing here. That was very dumb. Oh, now it passes the test. We had done the that was so stupid. If I had run the input, maybe I could have had the answer. Let's do that. Let's run cargo run 23 and have I don't care about the printing. No, actually this is not the real input. Let's go with the real input. And it took some time to run, but we have an answer. Let's just go with that answer and see what happens. Yes, okay. It wasn't so difficult. Like we actually did the logic correctly, but the problem was the format of the sample string. That sucks. I would really like it if Rust had like indentation sensitive or like macro or something to say like didn't. Of course, it's full of things like that in the Rust packages, but I mean, in the standard library, it would be nice to have something like that for cases like this. But okay, that was part 1. I think I will check what part 2 is about and maybe do some final touches to the code and call it a day. So, part 2, a very small part 2. Part 2, it seems you are on the right track. Finish simulating the process and figure out where the elves need to go. How many rounds did you save them? In the example above, the first round where no elf moved was round 20. Okay, figure out where the elves need to go. What is the number of the first round where no elf moves? Okay, so we need to be aware when no moves are made. That condition is going to be very simple to code. So let's comment out the printing. And what I want to have is something like, well, I guess we can have yeah, this is not necessary here. This calculation of the empty tiles at round 10, I think we can put it inside of here. So we are doing the rounds. This is first part of the round. This is the second part of the round. Then we can say something. Okay, let's start rounds at 1 and go indefinitely. And we can say, hey, if round equals 10, we're gonna do something like this. And we can have just a mutable variable for this. Let empty tiles at round 10, very explicit. We're gonna just start at 0. It's not the most correct code, but whatever. And we're gonna say, okay, empty tiles at round 10 is gonna be this thing. And here we're gonna print that. And let's break now. So this should still run the same for, yes, for part 1. I'm actually like going straight forward to try to see if part 2 runs. Like I was planning to call it a day after part 1, but part 2, unless it's computationally very expensive, which is a very real possibility, should be pretty straightforward, I think. So the condition that we are not going to break out of here. We're just going to do this when on the round 10. What we are going to do, however, is to say if proposed moves is empty, then break. And I think we should, I don't think I can print the round here right now because it's over here. So what do I want to do? I guess we can have a variable for that. Round started, yeah, started 1, I guess. And we're just going to simply loop over here. Oh, by the way, it was very weird that I started at 1, but this round, when started at 1, should have changed this direction index, which should have changed should have changed the answer for, oh, we are not breaking because maybe proposed moves, oh, maybe because it was taking too long, right? Yes, it's, I think so, or something else I screwed up. Yeah, and I screwed up here because this changes the answer. We have to, if we start again at 0, yeah, now it says 110, which is a bit suspicious, but okay. Let's start round at 0. We're gonna just loop. We're gonna, after this, we're going to, after this thing, we're going to consider the round complete, and we're gonna say plus equals 1. Then do the check for round 10, and then do the empty check of proposed moves. Let's see now. Yeah, now it prints 20, which is what we want to see. Actually, we should update the test to say, hey, part 2 is 20 for the sample, which is very good. But now for the actual input, let's run it in release mode and see. Why is this thing called, oh, it didn't take that long. 1010. Is this the correct answer? And it is. Okay, part 2 was a breeze. That's really, really cool. We can clean up some stuff. But I think that's gonna be it. And the code is not even that messy. Are we using these points for too much? I don't think we are using, like, we are using it for all these constants. But then now we're not really using, so you know what, I think like this this is one of those rare cases where all the code is, almost all the code is inside of the run function. I don't think maybe I can extract some of this, like this could go into a function for sure. But one of the advantages of having everything in the same function is you don't need to extract things into constants. You can just put these things into variables here. And if they are variables, it's like they are easier, like they don't need type declarations. And well, I guess who's complaining about this? Yeah, naming conventions. Well, we could have this as constants. It's also not a problem having them, I guess. I just wanted to clean up like the necessary type annotation. That's whatever. Yeah, I think this is all right. The parsing code is all right. This is pretty straightforward code. We can also clean up this unnecessary printing now. And yeah, so this thing runs in about a second, which is not great. I have been trying to optimize things a bit, well, and now it took 2 seconds. Maybe without recording on OBS, this would take less, but still it's going to be like maybe half the time. But I wanted to have like very fast times for this, and this surely is the case where things are taking so long because of all the hashing that is being done. Like in each round we are iterating all the elves, and for each elf we're like hashing there are 8 neighbors, like, and multiple times, so 3 times 4, like 12 hashes, and you know those operations add up. So I'm wondering if maybe this would run faster if done on a 2D vector for the grid, and maybe the elves, instead of being in a, like, the elves could be just in that 2D vector. Yeah, this could probably be optimized quite a bit, I think. Yeah, maybe the only hashing that we would need is for the moves. But in any case, that will be for another day. For today, I think this was quite fun and quite an easy challenge, I would say, compared to, well, especially compared to the previous day for the cube thing. So yeah, let's just commit this. I'm a bit tired already, so I'm starting to lose focus, the little focus that I have. So let's call this a day. Let's commit this as day 23 solution. And that's it for today, I think. If you have been, thanks for watching, and see you later. Bye-bye. Well, actually, let's try one last thing. I just noticed maybe a couple of little refactor ideas before calling it a day. I generally do that, like after making a commit, I still look for improvements to make, or things to simplify. There is one thing that I would like to try, is maybe removing this move enum and trying out how it looks, how this thing looks with just using a result variant for this. So like when too many elves collide, or more than one elf wants to move the same direction, we're just going to say, hey, error in that case, and otherwise we're just going to say this is okay, which I sort of like those names. So those are the variants, and we don't need here to, I guess, say this. And the inferred type is going to be from a point and to a result of this. And we can, I guess, put a comment here if there is already another elf wanting to move to this destination, mark it as like that, move as a collision. I don't know if collision was the name that was given in the here, collision. Two more elves. Yeah, it doesn't say a name for this. There's already another elf. Don't consider either of those moves. Yeah, okay, that's fine. And I think it's just a simple simplification. Like maybe this was more explicit, but whatever. And the other thing that I wanted to try out was to move these constants over here. Like they are only being used for the construction of these directions. So we can also make a temporary block here and put everything of this inside of here. And now, yeah, maybe we can try changing this into simple variables, and I guess we can lowercase these things. It should be no problem because these names are not escaping anything, so they are very local to this. And yeah, this should work the same as before. It does, and I'm just kind of putting everything in the same function. And I think this point, where is this thing being used? Only here, of course. It doesn't need to. Like, it doesn't need to exist if we don't have many functions like taking that and, you know, giving it some meaning for existence. Like, it doesn't need to exist. I'm almost tempted of inlining also these parse elves, but I think that can leave as a separate function. So yeah, I think I quite like this. Yeah, it's kind of everything in the same place, but that's fine. That is fine indeed. I'm checking this thing quickly. Yeah, this looks alright. And surely there probably is a way of not doing this round and loop, and I'm using a 4, but I'm not sure what I'm missing. So yeah, that's simple refactor that I wanted to do. So let's add it and amend it into the previous commit. And yeah, now that is it. Now it's the end of the video. See you later. Goodbye.